Assalamu alaikum. Welcome to the short description of the laboratory work in the course. You are of course in manufacturing processes and we are describing lab experiments here. The lab manual and the lab videos, the lab manual has already been posted on the course Moodle. It contains complete detailed descriptions, a small theoretical background, the procedural steps, if required, the pictures of the machine, what tables and graphs you need to write, and everything, right? So the lab manuals are there. Lab manual is already there on the course Moodle. And all lab videos are available through the web links sent to you by email, right? I have sent you an email. I have told you that Engineer Abdullah Al-Umrani has done a lot of hard work and prepared actual videos where he is conducting all of the experiments. So links to those videos are already posted on the Moodle, and out of the 4 experiments, one was directly available on the Moodle, right? It is not as a link. The others are available through the link that we sent you through emails, and one of them about the NDE, non-destructive testing or non-destructive evaluation, is directly there on the Moodle. Now, after going through my video lecture, which we are just doing, and the lab manual and the lab videos, right? You have now, I have done this video lecture, and these slides are also available as a PDF on the Moodle, and the lab manual is there, and Engineer Abdullah Al-Umrani's videos are there. So after going all through this, if you have any further questions, please contact Engineer Abdullah Al-Umrani. His email is given here, if you can read it, or otherwise go to the mechanical engineering website at SQU and you will find his email anyhow. If you were physically here in the university and so on, then beside the mechanical engineering department, there is a block C. Some of our teachers sit there also, and there in block C on the 2nd floor, there is a CIM lab, Computer Integrated Manufacturing Lab, and Engineer Abdullah Umrani is generally found there. Also, there is a solid mechanics lab, so he can sometimes be found in the solid mechanics lab or in the CIM lab in block C of the university. For submission of lab reports, I have already told you through the emails and so on, you have to make groups of 4 people each, 4 people. And there will be 1 report for 1 lab for each group. So the 5 people in the group together will write only 1 lab report for each of the labs. So if there are 4 labs, then there will be 4 lab reports required by each of the groups. Any one person from the group should submit all the reports through the Moodle, right? Anyone can become responsible. When you are writing it, when you are understanding it and so on, you can work as a group. Once you have finished working on it and the reports are ready, then any one of you can upload it. And the file name, lab number, lab 1, lab 2, lab 3, lab 4, the ID number and the first name of any one team member, so that I can know whose lab reports these are. I remember sometimes people submit it and you think you are saying lab 1, but you see there are 15 groups who are doing lab 1. So unless you have your ID number of first name there, at least of one person in the group, then I would not know what it is, and it is to be submitted through the Moodle, of course. Now these are general guidelines for writing lab reports. General guidelines. These are not for only manufacturing. If you were doing materials with me, if you were doing engineering materials, if you were doing any lab, even in the thermofluids group or wherever. So please read the lab manual carefully and follow all instructions, right? This is important. Each student group should work independently on the lab assignments. Copied reports will be given 0 grade. Very important. You see report from one group, report from the other group. If there is too much of similarity, By chance, very small similarity I can understand. But if there is serious similarity in two different lab reports, then both of the lab reports will be given 0. I am not bothered to do an investigative work that these guys did the original work and these guys copied, because you know that copied work is not allowed. Each group write their own reports. Therefore, the group that allows their report to be copied is as guilty as the group that is copying, right? So please do your own reports. Preferably, of course, reports should be typewritten. Handwritten reports can be given, but it is very tough. You can make a lot of mistakes and this and that. So if you are typing them, then it is much easier for you also to handle it and then to incorporate any pictures or tables or graphs and so on, right? So now each lab report should contain the following sections. There should be a cover page for each lab, which includes the course name and the number, the semester, the experiment number, the title of the experiment, and the names and IDs of the students in the group. So make this cover page and just keep on adding this cover page to each one of them. The only thing you have to change is the experiment number and title. All the other things, course name, course number, semester, student names, student IDs remain the same. So just make one cover page and then keep on using it in the other experiments by changing the experiment number and title. Objectives should be clearly written. What are the objectives of each of the experiments? Introduction should be there, reasonable, so that you introduce what you are doing in that area, the small background from theory, from general work and so on, right? It should be there. Apparatus and materials. What are the machines, equipments, tools, materials that are used in that experiment? The procedure, step by step, 1, 2, 3, 4, 5, step by step, that from the beginning till the end of the experiment, what are the steps to be followed? Results and discussion. What are the results from the experiment? Sometimes there are values given in a table. Sometimes you can show them as a graph. Sometimes you are taking some pictures of showing some defects and so on. So whether they are tabular values, tables, whether they are graphs, whether they are pictures from the experiment, they are results. And then discussion of these results, that these values or these graphical trends or these pictures show you what are you seeing inside. And then brief conclusions, that what did you do and what did you learn in this experiment. Of course, what I have not mentioned here, but we will show it later on, is sources of error. Every time in conducting every experiment, you should try to think that what are the different sources by which there could be some experimental errors, and you should discuss them. And again, in writing introduction and so on, right, or apparatus and materials, please try to build yourself up, not copy paste from different internet sites. You can always do that. But yes, you can go to internet sites, you can go to my lectures, you can go to the book to write about the machines and the introduction and so on, but write in your own words. Read from wherever, but write in your own words. So experiment one has two parts. One part is lengths and other dimensions, and the other part is thread, profile and angle. In the objectives, the first one, lengths and other dimensions, to measure and inspect the lengths and other dimensions of various components. You see, you know, length, thickness, diameter, radius, these things are dimensions. So how to measure them? The second is thread profile, thread, if there are some threads and angles. So to identify the thread profiles and to measure their angle dimensions, angles. I am just showing you pictures from your lecture here, right? The micrometer, the vernier calipers and so on, because these are related to measuring the dimensions and so on. Here I am showing the optical comparator for enlarging the angles and views and so on. So in the apparatus and materials, list the various types of equipment and tools used in these experiments and the materials or specimens that you were testing. Materials or specimens. Again, there will be two, right? this list of apparatus and materials, one will be for lengths and dimensions, the other will be for thread profile. And then similarly procedure. Write the step-by-step procedure used in both the tests. What was the procedure that you did here? All these steps, what were the procedure that you did here? Okay. These pictures and so on, I'm just showing you that you can go back to the lecture notes or the video lectures and say that this experiment belongs to this part of chapter 4. Results and discussion. Results and discussion. For lengths and other dimensions, show all the measurements in a table format and discuss your results. For thread profile and angle, make a sketch of each workpiece and show all measured dimensions for all workpieces, discuss the results. Right? Whenever I say a sketch, you can make a very clean, neat hand sketch where things are shown, or you can quickly do it in Word Draw or AutoCAD or SolidWorks, whatever you feel like. I am not asking you to do extra work, but the clearer your lab report is, the better marks it will get, and so on, isn't it? So, here in this one, make a small sketch of each of the workpiece. You take a workpiece and then you do the thread profile and the angle and so on. So make a sketch. Okay. And then for both experiments, discuss the various sources of errors. Discuss the various sources of errors. So how, if I were you in your group and we had to write this, then what will I do is that experiment 1, I will say part A, lengths and other dimensions, and I will complete everything, right, from introduction to procedure to equipment to results and discussion, everything and sources of error for part A of experiment 1 I will complete. Then I will say part B or whatever, part 2, thread profile and angle, and then do all the steps rather than jumping here and there, so that, right, this is experiment 1. Inside a small 1 or A is lengths and other dimensions. So you go back from the beginning, objectives, introduction, apparatus, equipment, procedure, results, discussions, errors, all of them for 1, and then you do the other one. Will make it much more logical and well organized. Experiment 2 is about surface roughness. Surface roughness, right? So again, I'm just showing you which part of the lectures and so on related to this. To measure surface roughness parameters RA, RQ, RZ, RP, RV, etc., you see the manual, it will be described there. For 5 samples, if there are exactly 5 samples, okay, otherwise whatever number of samples are there, having different surface finish produced by different manufacturing processes like turning, milling, drilling, grinding and lapping honing. So if you were doing the actual experiment, then we had taken certain metal alloy pieces and we had prepared their surface by general turning, by milling, by drilling, by grinding and by lapping honing. So different types of surface roughnesses or surface finish are there because of these different machining operations, and then you study them, right? In the apparatus and materials, of course, there will be a portable type of surface roughness measurement device, which you will see in the video. So list the various types of equipment and tools used in this experiment and the materials specimens that we just described, right? So list all of them and what are they and so on. In the procedure, of course, again, right, write the step-by-step procedure used in the surface roughness experiment. In results and discussion, show the charts printed out by the surface roughness measurement device, summarize the measurements in a table format, discuss the results and discuss the various sources of errors. Okay, so this you should understand by now that we are requiring the same type of things in each experiment.